Hello, this question is from GATE 2018 and the question states which one of the following represents the 3p radial wave function of hydrogen atom where A0 is the Bohr radius. So you can see there are four options given in which the plots have been made in form of r as a function of uh, the coordinates polar coordinate r small r and as with respect to the r upon a naught. So these are the four options. So let us start solving the problem here. Now we know that the radial wave function of hydrogen atom has the form of r n l r equals root under 2 upon a naught whole cube and n minus l minus 1 factorial divided by twice n plus l factorial whole cube, then e power r upon a naught and twice 2 by n r upon a naught to the power l, then l n minus l minus 1 twice l plus 1 twice r upon n a naught. Okay, where the function l mn of x is the associated Lagrange polynomial. Okay, and also we can say that L m n x can be written as x power minus m e power x divided by n factorial, then dy dx to the power n e power minus x times x power m plus n. Okay, so this is the form of this Lagrange polynomial, and putting okay, so the state is given as 3p. Okay, so for 3p state we have n equals to 3 and l equals to 1. For p we know that l equals to 1. So if you put this value r31 as a function of smaller because of the radial wave function, so you will get something like 8 by 27 root 6 a power minus 3 by 2 1 minus 1 upon 6 r by uh, just let me go with a naught as the Bohr radius r by a naught times r by a naught exponential minus r by 3 a naught. Okay, so this is the general form. So I can write it as capital A times r by okay, capital A times r by a naught into 1 minus 1 upon 6, uh, or it is better to put a variable in place of r by a naught first. So put r by a naught equals to r prime, and 8 by 27 root 6 into a naught to the power minus 3 by 2 as a constant capital A. So this will make r31 as a function of r equals to a times r prime times 1 minus r prime upon 6 into e power minus r prime upon 3. Okay. So first let us find the zeros of r31 function of r. So this will make that is r prime times 1 minus r prime upon 6 into e power minus r prime upon 3 equals to 0. So this will mean that r prime equal to 0 will give the entire function 0. Then r prime equals to 6 will also give the 0 due to the second factor. And for the third factor, r prime should be infinite. So e power minus infinity equals to 0. So r prime will be infinite. Now let us check the solution or the options. So r prime should be 0 at this point. R of r prime equals to 0. Okay, at 0, 6. So at option A, at r equals to or r prime equals to 0, r has a non-zero value, so option A is incorrect. Similarly, option C is also incorrect. So at r equal to 0, uh, or at r prime equal to 0, both option B and D has a value 0 for r, radial wave function capital R. So now for option B, you can see there is a 0 value in between. Okay, but here there is non-zero value. So I think this value is r prime equals to r upon a naught equals to 6. So here you can see this value is satisfying, whereas here only two zeros are there at r prime equals to 0 and r prime equals to infinity. So this makes option B as the correct option. Thank you.